Given the function f of x equals parenthesis x minus 1 squared times parenthesis x plus 1 squared, find the sketch with all intercepts and the proper ends. Okay, let's just zip through this quickly. The degree of this polynomial, if we expanded it, is a fourth degree polynomial. It's an even degree. The lead coefficient would be 1, and that's positive. That implies both the left and the right far extreme sides are going to be moving upward. And we have the sketch with the y-axis, the x-axis, upward on the right, upward on the left. Now let's make our table. We're going to list the zeros, the multiplicity of each of the zeros, whether that x-intercept is a cross or a kiss, and the actual x-intercept. The first zero, the number being subtracted in the first parenthesis, is positive 1. The multiplicity is the power on the outside of the parenthesis. It's a 2, which means it's even multiplicity. That indicates a kiss for the x-intercept at 1, 0. Negative 1 is the number being subtracted in the second parenthesis, so our 0, our root, is negative 1. The power outside is a second power. It's kind of messy, but that's what it is, a second power, which means it's even multiplicity. And that indicates we'll have a kiss at our x-intercept, which is the ordered pair, negative 1, 0. Now we're going to do our pre-sketch information using a sign graph. So we'll make the x and y axis for our pre-sketch information. Okay, so here is our, our x-axis, our y-axis. Like I say, it's probably easier if you don't put the y-axis in there. Here's our factor, our first factor squared, our second factor squared. You know what's so cool? And then the product of the two factors is our polynomial, our entire polynomial. So we're going to identify the location of each of the roots, negative 1 and positive 1, and do a dotted line down those. Okay, so there's 3 regions. Don't consider the y-axis as busting anything up. The dotted line's busted up into 3 regions. The cool thing is that each of the factors is squared. If you square any number, it's going to be positive. So in all of these regions, the first factor will be positive and the second factor will be positive. They'll multiply together and give us a positive result for the polynomial. It happens in all 3 regions because of the squares. Okay, so what's happening here is to the left of negative 1 we're positive, to the right of negative 1 we're positive. So I indicate that with those little short arrows. I'm not telling you how far it goes. I'm just showing you what happens immediately on the left and right of the root. And on the last root, x equals 1, to the left it's positive for the polynomial, to the right it's positive. So they're all above the x-axis. So once again, the pre-sketch info, that shows us the behavior on both sides of each of the zeros. Now there's one more thing we need to do before we do our graph, and that's to find the y-intercept. The y-intercept is f of 0. F of 0 is equal to parenthesis negative 1 squared, parenthesis 1 squared. You multiply that together, and you're going to get a 1. So the y-intercept is the ordered pair 0, 1. Okay, so let's put the sketch together. Our y-axis and our x-axis. The roots at negative 1 and positive 1. Those are the x-intercepts. The y-intercept at positive 1 on the y-axis. And looking at the pre-sketch info, keeping everything in the positive region above the x-axis on both sides of all of the x-intercepts. And there is our graph.